Okay, I've taken this lesson. We're going to actually take 2 days on this lesson, all right? So this is kind of like, we'll go half and half. This is the first thing. Let me grab a triangle here. This is the first thing that we're going to talk about. And I'm going to just spend this class period just talking about this one thing, and then tomorrow we're going to do another one. If I could grab this thing, come on. Does not mean no homework. I still have homework for you. Oh, why do you act so disappointed? We always have homework, right? It shouldn't be any different. Don't be sad. You should look at it as an opportunity to learn the material and to do well on the test. Aren't you happy when you get a good grade on a test? Who's sad if they get a good grade on a test? Is anybody sad? No, you're happy about it. Now, how do you get a good grade on a test? Okay, you don't just study, but you do your homework, right? If you do your homework consistently and you try it and you try to do your very best, then you will succeed and you will be happy. So a little bit of sad by doing your homework turns into happiness when you get a good grade on your test. Wouldn't you agree? Aren't you happy when you got 100 on your test? Sure, I could see it. You were just thrilled to death. All right, and and it's because she does her homework all the time, and she's always showing her work, and you can see 100% effort when she does her homework, and it shows on her tests. Okay, and so even though you might be a little sad because you have homework, you got to look at it as a good opportunity to get a good grade on your test. All right, enough of that. I don't even care about the. I guess we do care about grades, but um, that's not really what I'm trying to teach you for. I'm not trying to teach you to get a good grade. I'm trying to teach you to learn the information. That's what you should want to try to do. And I know you don't. You're kids, and you don't really care about the learning part of it. But later on in life, I think you will. I think you're going to get a much better appreciation for actually learning stuff when you get older than you do right now. Right now, you're like, it's just something you have to do, and it's something you got to struggle through and just get through, and I can't wait till it's over. But I'm telling you, when you get older in life, you're going to look back on this and think, man, I wish I would have tried just a little bit harder. I wish I was a little bit more interested in this material, not just geometry, but I'm just talking school in general. Okay, I promise that's one day you're going to be saying that kind of stuff to yourself. Bet you anything. All right, so here we go. What do we have here? We got a triangle, and it's a right triangle. Now, I didn't mark anything else on here, but what does it kind of look like might be true about this side and this side? What do you think? Yeah, they're equal to each other. Exactly right. So let's mark them equal to each other. So what kind of a triangle do I have now? Besides a right triangle, that was obvious. I've got two equal sides. What isosceles? Good. We got an isosceles triangle. So that's old stuff, right? We already knew that. If we have an isosceles right triangle, and that's what we have right here, isn't it? What do I know about this angle here and this angle here? I know they're equal to each other because on any isosceles triangle, the opposite angles will always equal each other. Everybody see that? And we learned that before. Do you remember learning that a while back? If you have an isosceles triangle, if the two sides are equal, the opposite angles are equal. Yes? Does that ring a bell at all? Okay, good. So if these two angles are equal to each other, I can get a little bit more specific than that. I can tell you, or you can tell me, exactly how many degrees both of those angles are without putting any numbers in there. What would they be? 45. How'd you get 45? Right. Yep. Divide 90 by 2. Okay, 90 divided by 2. How'd we get 90? Well, because these two have to add up to 90, don't they? Because 90 and 90 is 180. And then 90 and 90 divided by 2 is what? 45 degrees. So that's 45 degrees. And that's 45 degrees right there. So we have a special triangle called a 45, 45, 90 triangle. All right? Not much of a stretch to call it a 45, 45, 90 because that's the angles in that triangle right there. Okay? Now, big deal. So we got a 45, 45, 90 triangle. I'll tell you what, let's grab this one right here. Let's copy that one and paste it. Well, it is kind of a big deal because we're going to learn something about this. Now, what I want to do is I want to show you how we're going to get. I'm going to give you a little formula, but I'm not just going to give it to you and say, here it is, let's memorize it. This is a very easy one to kind of figure out on our own. Tomorrow, what we do tomorrow, it's not quite as easy to figure out as this one, so I probably won't show you how we get the formulas for tomorrow. I'll probably just give them to you. All right, but today's is pretty easy, and so I can do that for you. Watch. Let's call this. Let's just call this side x. If I call this side x, and these two sides are equal to each other, what would I call this side down here? I would call it x as well. I wouldn't call it y or z, would I? Because they're what to each other? They're equal. So if this is x, then this has to be x. Now this is the hypotenuse. Let's just call that h for hypotenuse. Is that all right? You can call it anything, but I figured h works pretty well. What I want to do is I want to find some kind of relationship. Let's do Pythagorean theorem and actually solve for h. Okay, so let's do Pythagorean. I don't have any numbers at all, do I? All right, but I want to get h by itself. I want to get h equals whatever. All right, so what are we going to do? Pythagorean theorem. Well, it's not going to be x. No, not h equals x plus x. Pythagorean theorem. X squared, right. So h squared, I'll just do a little h, is that all right? So h squared is equal to what? X squared plus what? X squared, good. Well, it's not x cubed. Let's continue with this. We can't really do anything with h squared. What about this? How do you add those together? That's 1x squared plus what? 1x squared. No, if I have 1x squared, and then I add it to another x squared, how many x squareds do I have? I got 2 of them, right? So it's 2 what? X squared. I don't add the exponents. Okay, I just keep it the same. It's like saying 1 apple plus 1 apple is what? 2 apples. It's not 2 apples squared, is it? It's just 2 apples. So it's 1 of these plus 1 of these gives you what? 2 of these. Got it? Okay. We want to get h by itself. We're almost there. How do we get h by itself? We did a whole chapter on this last chapter. Take the square root, right? Isn't that how you get rid of a squared? Right, we did that all last chapter with that, was it last chapter? No, I guess it was the beginning of this one when we did that geometric mean stuff. Do you remember that? Yeah, so we had like a couple days where we did that stuff. So how do you get rid of this? You square root it. You square root that. So that square root gets rid of this square, doesn't it? And that just makes it h. Now, what about this? Is that how we're going to write it? Nah. Watch, we have a little rule in algebra that says this. If I have the square root of ab, that's equal to the square root of a times the square root of b. Do you see what I just did? If I have two things being multiplied together under one big square root, I can separate them like this. They're still being multiplied, but I can separate them under their own square root. So what does that do here? What can I do? I can say the square root of 2, can't I? And I can also say the square root of what? X squared. We're almost done. What's this? Can I do anything with the square root of 2? No. I'm not going to put it into a calculator, just going to write it square root of 2. What about this? What's the square root of x squared? It's x. And look what I just did. I just got h by itself. I just solved for the hypotenuse. And I don't even know what these sides are, do I? It's just some variable, just x. But this is really super important right here. That h, the hypotenuse, let's write this down. I'll just shorthand it. The hypotenuse is equal to what? The square root of 2 times x. Well, x is one of the legs of the triangle, isn't it? So watch what I'm going to do. I'm going to write it like this. The hypotenuse is equal to the square root of 2 times one of the legs. Does it matter which leg? No, why not? Because they're the same, right, exactly. So it doesn't matter which leg because they're both the same on a 45, 45, 90 triangle. So that's super important. It's so important, I'm going to put it in a little box right here. You know it's important when I put it in a box, right? That's our formula, okay? But now we got to figure out how we're going to use it. All right, that's our formula, which means what? The hypotenuse, is it twice as big as one of the legs? Is it 3 times as big? No, it's what? It's the square root of 2 times as big. And what in the world is the square root of 2 anyway? Well, let's punch that in there and see what we get. 2, oops, let's clear that. The square root of 2, it's about 1.4, okay? So what does that mean? That means that the hypotenuse is about 1.4 times as big as one of those legs. And that works no matter how big or small your 45, 45, 90 triangle is. Follow me on this? So it's not twice as big, is it? It's not even 1.5 times as big. It's just a little bit smaller than that. It's about 1.4. But we don't use the 1.4. Don't get me wrong. Okay, I don't want to use the 1.4. I'm using this, the square root of 2. So let's do a quick little example. This is about the easiest example that you'll see with this kind of problem. Let's push that up to the top a little bit. And Watch this. It's a right triangle. These two sides are equal. If these two sides are equal, then it's a 45, 45, 90, isn't it? And let's say this is 5. And they want you to solve for x and y. And this is what they tell you to do. All right? They give you a situation like that, and they say solve for x and y. Yeah, x is the easiest one. Okay, you don't hardly have to think about that, do you? So x is 5. Would you agree? All right. Now, this is the hypotenuse, isn't it? Let's write down again our little formula. What's our formula? The hypotenuse is, it's not 2, it's the square root of 2 times what? Times one of the legs. Okay? So let's use this formula to figure out what y is. Well, y is the hypotenuse, isn't it? Right? So what's it equal to? It's equal to the square root of 2 times what? Times one of the legs, which is 5. I'll just write it like this. But do we write it like that? How do we write numbers in square roots? We put the whole number first and then the square root second. And that is all you have to do. Did I do any math at all? I didn't do any math. Didn't do any arithmetic. All I had to do was understand that if I know one of the legs, I can find the hypotenuse just by multiplying it by the square root of 2. So it's 5 squared of 2. No work involved. You know how I always say, show your work, show your work? There's no work to show for this. There's nothing. All right? If they give me a leg, I can find the other one. That was the easiest thing. And I can find this as well. All I got to do is just stick that next to a square root of 2, and I'm done. That's almost as easy as figuring out what that one was, isn't it? It's not much more difficult. What do you think? Does that make sense? So the hypotenuse is 5 squared of 2. Let's do another one. Let's drop this down a little bit. There we go. Let me make this just a little bit tougher. What if I said that this was the square root of 7, and this side were equal, and again, I wanted you to solve for x and y. What's the easiest thing to find here? The x. All right, and what is x going to be? Good, square root of 7, because those two sides are equal to each other, so that's pretty simple, right? But now we got to solve for y, which is really not that much more difficult. So how do we solve for y? The hypotenuse is equal to what? The square root of 2 times one of the legs. So what is it? It's the square root of 2 times what? The square root of 7. But we don't leave it like that. How do you multiply those two together? They're both under a square root. Up here, this 5 was not under a square root, was it? All right, so you couldn't combine them together. All right, you just keep the whole number out front and stick it right next to the square root of 2. But what about this one, though? You multiply them together. Remember that rule with that a and b right here? Remember this? If I have two things multiplied together and they're both under a square root, what can I do? I can just put them under one big square root and multiply them together, right? Does that make sense? So let's go back to this again. So what's this going to be? Square root of what? 14. And that's your answer right there. Just leave it like that. I don't want a decimal. I want square root of 14. That's an exact answer. That's a little bit, that much. Tiny, tiny, tiny bit more difficult than one we did earlier. Right? But it's pretty easy, don't you think? Yeah, I think so. All right, so if they give you the leg, the square or the hypotenuse is a piece of cake. All you got to do is multiply by square root of 2. Boom, you're done. Let's do one. I'm trying to think what I did in the other class. Seems like I did another one. Oh, I know what I did. Okay, we'll do this. Let's go with yellow. Oops. Let's do the writing in yellow. There we go. All right. What if I did this? Watch this. I really mess with you now. What if I did 3 square root of 2, and I told you that and that were equal to each other, and I asked you to solve for x and y? It's a little different, isn't it? This time, I don't give you the leg, I give you the what? Hypotenuse. Well, let's write that formula down. You write this down about 5 or 6 times, and you won't forget it. Okay, the hypotenuse is what? The square root of 2 times one of the legs. Let's fill some stuff in. What do we know? We know the hypotenuse, don't we? which is what? 3 square root of 2 equals, let's finish this off, square root of 2 times what? One of the legs. Yeah, you could use x or y, couldn't you? It doesn't make any difference because they're the same thing. Now, how do I solve for x? I don't multiply by the square root of 2 this time. What do? I divide by the square root of 2. That's right. See that? So if I knew this number, how would I get the hypotenuse? I would multiply this by square root of 2. So what did I have to multiply this by square root of 2? Or what number did I have to multiply by square root of 2 to get this? Nobody sees this? Everybody's just staring? 3, thank you. It's a 3, right? Because look what I did. I divided by square root of 2, divided by square root of 2. That canceled, that canceled. X is what? 3. So it makes, and then y is the same thing, right? X and y, even though they're different letters, they're the same exact thing. That's 3 and that's 3 because both of those sides are the same. So let's recap. If they give you the hypotenuse, how do you find the leg? What did you do? You divided by the square root of 2, didn't you? Okay. If they give you the leg, if they give you this, how do you find the hypotenuse? You multiply by square root of 2. You get it? So if they give you the leg, you multiply by square root of 2. It's all because of this. Because watch, what if I wanted to get leg by itself? What's the leg equal to? How do I get leg by itself? I get rid of the square root of 2. How do I get rid of square root of 2? I divide. So what's the leg equal to? It's the hypotenuse divided by the square root of 2. Follow me? Okay. This was actually kind of an easy one because I gave you this as 3 square root of 2. When you first saw it, you probably thought, oh no, he's really making this hard. But I actually made that kind of easy for you by putting 3 square root of 2. Why? Because the square root of 2 cancels out, doesn't it? All right, so I kind of made that easy for you. What if I did this? Let's go to, what haven't I used yet? Let's go to this dark purple. Let's go to this raspberry. How's that? Sounds good. Sounds tasty. Alright, what if I do this? What if I said this is 13 and I ask you to solve? I'll tell you what, instead of calling it x and y, let's call it x and x because they're the same thing, right? So I give you this and I ask you to solve for x. Well, this time I gave you the hypotenuse. How in the world do I find the leg? How do I find the leg? Or instead of leg, x equals what? Do I take 13 and multiply it by square root of 2? I divide it, that's right. Okay, I take 13 and I divide it by the square root of 2. Now, I shouldn't really do this, but I'm going to let you do this. I'm just going to let you keep it just like that, 13 over square root of 2. I really shouldn't because, I don't know if you remember, let's do this very quickly. What time do we get out of here? So, 5th, 1:40. Oh, I've got time. I've got about 8 minutes, okay? So, watch this. Tell me if you remember this from Algebra 1. You might not remember how to do it, but at least maybe you're like, oh yeah, I remember them teaching it, and I wasn't paying attention or whatever, okay? So, if I had 13 over the square root of 2, this is actually not simplified. Some math person a long time ago, I have no idea who did it and why, but they decided this is not simplified. We can't leave it like this, all right? Not really sure why, but a lot of math classes, they're going to make you change this answer. You will not be able to use this as an answer to your problem, especially in your algebra classes. So how do we get rid of that square root in the denominator? Remember, the math people say you can't have a square root in the denominator. Well, we have one, don't we? So how in the world do I get rid of it? Well, I'll show you. Watch. I'm not going to go through a big, long explanation, but I will do this. What if I did this? Multiply that by square root of 2 and multiply that by square root of 2. Look at the blue right there. What did I just do? I basically multiplied by what? What's the square root of 2 over square root of 2? What's anything over itself? It's a 1, isn't it? So I just multiplied by a 1. Does that change the value of this at all when I multiply by a 1? No, it doesn't. Okay, just multiply by 1 stays the same thing. But guess what it does? Look what it does. Look at the bottom. If I multiply these together, what is the square root of 2 times the square root of 2? Well, it's the square root of what? 4. What is the square root of 4? It's just a plain old 2. Look at that. So we got rid of the square root, didn't we, in the denominator? Now, we're allowed to have one on the top in the numerator. We just can't have one on the denominator. So that's a 2. What's the top going to be? What do I do with that? I just write it 13 squared root of 2. That's my answer. That's technically how you should write your answer. I'm going to let you just keep it like that. Okay? If you want to keep it 13 over square root of 2, it's okay. For now, all right? But when you take an Algebra 2 class, they're not going to want you to keep it like that. They're going to want you to write it like this. Tell you the truth, I just kind of think it's a silly idea to have to change it to this, but you know, whatever. You might have classes where they're going to make you do it, so I thought I'd show it to you. All right? And that's about as hard as it gets. If you get a whole number for the hypotenuse, what do you do with this? You just divide it by square root of 2. Boom, you're done. It's really pretty simple once you learn the little ins and outs of this thing. All right? So I'm going to give you a worksheet on section 8.3. But you only have to do 1 through 8. Remember I said we're only doing half the worksheet because there's some other problems on there you won't know how to do until we hit tomorrow, okay? So I'll give you the rest of the worksheet tomorrow. But tonight you should be able to do 1 through 8. It's all 45, 45, 90 triangles. So it has to do with all of the stuff that we talked about today. Okay? All right. I'll give you the worksheet, and then it'll almost be time to go.